In this video, you will learn how to convert equations in polar form to rectangular form. Now, how to convert an equation given in polar form in the variables r theta into rectangular form in x and y. So all we have to do is to use the transformation relationships between the two sets of coordinates, which are x equals r cosine theta and y equals r sine theta. So you just have to remember that the equation may need some algebraic or trigonometric manipulations before being transformed into rectangular form. So let's solve some sample problems here. Okay, say for example we're given a polar equation which is r equals 3 cosine theta. So let's convert this polar equation into a rectangular form of equation. We just have to manipulate this equation here. We can rewrite this as r squared equals 3r cosine theta. So they are just equivalent. You just have to divide this by r, both sides, then you will get the same equivalent equation as r equals 3 cosine theta. All right. Now let's substitute the values or the value of one of the sets of coordinates. So we have here r squared, and we know that r squared is just equal to x squared plus y squared, and then r cosine theta is just equal to x. Alright, so we can just plug in all these values here in this equation. So r squared is just equal to x squared plus y squared equals 3 times r cosine theta is just equal to x. So this is now our equation in rectangular form. And we can further simplify this. We can move 3x to the left. Okay, I transpose 3x to the left. So we have x squared plus y squared minus 3x equals 0, and then we group x squared and 3x, so x squared minus 3x plus y squared, and then we can use completing the square. We complete the square. We just have to add this one, x squared minus 3x, by the square of half of the coefficient of the middle term. So the middle term here is 3, negative 3. So we just add x squared minus 3x by the square of negative 3, or half, or the square of the half of negative 3. Okay. Then plus y squared equals, okay, whatever we add on one side, we also add to the other side. So we added negative 3 halves squared to the left, so we should add negative 3 halves to the right. So that is 0 plus, it should be 0 plus negative 3 halves squared, which is just negative 3 halves squared. Okay, and then we can simplify this now. So our equation would be x squared minus 3x plus 9 over 4, then plus y squared equals 9 over 4. And then we can write this as the square of the difference. So that would be x minus 3 halves squared plus y squared equals 9 over 4. So this is our equation now. Now let's solve another problem. Well, let's say we're given r squared equals cosine theta. Alright, we know that r squared is equal to x squared plus y squared, and x is equal to r cosine theta. So we have r squared here in our equation, so we can just simply plug in x squared plus y squared. But we only have cosine theta here. So cosine theta is just equal to x over r from here. We just derive this from here. Okay. And then for the value of r, we can get the value of r by getting the square root of both sides. That would be r equals the square root of x squared plus y squared. And now we can plug in all the values here. So r squared is equal to x squared plus y squared, and cosine theta is just equal to x over r. And then we plug in the values of r. X squared plus y squared equals x over square root of x squared plus y squared. So this is now our equation in rectangular form. Now let's solve another one. Alright, what if we're given this equation r equals 2 over 1 plus sine theta? Again, we can manipulate this equation or rewrite this equation as r squared equals 2r over 1 plus sine theta. So it would be easier to plug in all the values. Anyway, they are just equivalent. You just have to divide the second equation by r, and it will be equivalent to the original equation. We know that the value of r squared is equal to x squared plus y squared. So r is just equal to the square root of x squared plus y squared. And we know that sine theta, y is equal to r sine theta. Therefore, sine theta is just equal to y over r. And now we can plug in all the values into this equation here. So that would be r squared, which is equivalent to x squared plus y squared, equals 2 times r, which is just equal to the square root of x squared plus y squared, over 1 plus sine theta is y over r. Then we can further simplify this. Okay, we can write this as x squared plus y squared equals 2 squared of x squared plus y squared over 1 plus y over the value of r, which is x squared, square root of x squared plus y squared. And then we can further simplify this one. Okay, let's delete this. Okay, we can further simplify our equation. X squared plus y squared equals 2 square root of x squared plus y squared over 1 plus y over square root of x squared plus y squared. So we simplify the denominator. Okay, this would become, this one we can write this one, the denominator, as, okay, we get the LCD, which is the square root of x squared plus y squared. And then we have our numerator, square root of x squared plus y squared plus y. And then we can write the whole equation as x squared plus y squared equals 2 square root of x squared plus y squared over square root of x squared plus y squared plus y over square root of x squared plus y squared. And let's delete this. Alright. Then we can flip our denominator and change the operator sign to multiplication. So we have x squared plus y squared equals 2 square root of x squared plus y squared times the square root of x squared plus y squared over square root of x squared plus y squared plus y. And then we can further simplify this. We multiply this one and this one, and we have x squared plus y squared equals 2 square root of x squared plus y squared times square root of x squared plus y squared is just equivalent to x squared plus y squared, then over the square root of x squared plus y squared plus y. So this is now our equation in rectangular form, which is equivalent to r equals 2 over 1 plus sine theta.